Hi, how are you doing? Welcome to yet another video. And in this video, I want us to discuss applications of differentiation. There are quite a number of applications of differentiation, but when it comes to our national examinations, mostly for ordinary differentiation or for complete differentiation, they concentrate with two applications. That is the turning points and so turning points or stationary points and uh, equation of normal and tangents and equation of normal and tangents. So most but there are quite a number of applications of differentiation. Actually there are quite many, but we only limit our discussion to these two. If you have not checked the other videos, check them on the link shown here. We have discussed quite a number of methods of applications, and you need to go through that first so that you can be able to grasp the concepts of applications of differentiation. Let's see what we have in the past papers. We have this past paper, craft certificate in automotive engineering, craft certificate in automotive engineering, and we have question 5b. We are told use implicit differentiation to determine the equation of the tangent of tangent to the curve x squared plus dy squared minus 6xy is equal to 1 at the point 1, 2. So how do we go about this? We are going to differentiate this using implicit differentiation. So we are going to get the derivative with respect to x of x squared plus dy squared minus 6xy is equal to 1. When we differentiate x with respect to x, we get 2x. When we differentiate dy squared with respect to x, we get plus 6y dy dx minus, here we have to use product rule, so we take our u to be 6x, but I'd want to open a bracket here, so let us open a bracket. 6y is our u, no, 6x is our u, so we use 6x. If these are v, so we get dv dx. Derivative of y with respect to x is dy dx. We have already discussed how to differentiate using implicit method. I don't think now this is a problem. If you have checked my previous videos, if you haven't, check them on the link shown here. Now, so we have already determined u dv dx. We have taken u to be 6x, this is v. When you differentiate it, you get dy dx plus, now we get u dv dx. Now we get v du dx. Our v is y. When you differentiate 6x, we get 6, so that is 6y, and on the other side of the equation it will be equal to 0. So now if you open that bracket, it will be 2x plus 6y dy dx minus 6x dy dx minus xy is equal to 0. Let us rearrange so that we start with the values with dy dx and then we factor out dy dx. So here you have 6y, or we can just show that in the next step, minus 6x here dy dx. This and this, we take them to the other side of the equation, is equal to 6y. Take this to the other side of the equation and this to the other side of the equation, minus 2x. Factor out dy dx, so we have dy dx into 6y minus 6x is equal to 6y minus 2x. Now we divide both sides with 6y minus 6x, so that we get dy dx. Dy dx is equal to 6y minus 2x all over 6y minus 6x. So that is the derivative, and remember the derivative of a curve also represents the gradient of the curve. Like you have something, you are told to get the gradient of the tangent to the curve. So this is our curve. This is a curve, x squared plus 3y squared minus 6xy. So we are told now to get the equation of the tangent, this one, at a point, value of x is 1. Maybe at this point, the value of x is 1, and the value of y is 2. So we want to get the equation of that curve, or equation of the tangent, which is at this point. You get the derivative of y with respect to x at point 1, 2, where 1 is the value of x, 2 is the value of y. So wherever you have x, we put 1, wherever you have y, we put 2. So it will be 6 times 2, that is 12, minus 2 times 1, that is 10, 6 times 2, that is 12, minus 6 times 1, that is 6. So this will be 2 over 3. So dy dx at the same point, dy dx at point 1, 2 is equal to 6 or 3 is a third. So that is the gradient. But remember, with the gradient, you can find the equation. I'll remove the equation now. With the gradient of a line at one of the points, point 1, 2, you can get the equation of that line. You already have the gradient, and you have the as one of the points. So you can say the gradient change in y over change in x, which is m. We already have that. Change in y over change in x is equal to that. If we now take a general point, we can find the equation of the curve, whereby we can say y minus 2 over x minus 1. This change in y, this change in x. Remember, we have used a general point, any point in the line, anywhere point xy. So we are using point xy and 1, 2 to get the equation of the line. So this is equal to the gradient, which is equal to that. Now if we cross multiply, we now have 3 into y minus 2 is equal to x minus 1. 3y minus 6 is equal to x minus 1. So you can say 3y is equal to x. Take this to the other side of the equation, it will be plus 6 minus 1. Plus 6 minus 1 is plus 5. So that you can leave it at that. or you can put it in y is equal to mx plus c, which is equal to a third x plus 5 over 3. So that is the equation of the curve, or equation of the tangent. Sometimes you are also told to get the equation of the normal. Normal is this right here, that is making an angle of 90 degrees with the tangent. It's also easy because we know if we take the gradient of the tangent to be m, or gradient of tangent, although we are not told to do that, to be m, gradient of normal, of the normal, say this is m1, then m times m1 is equal to -1. So that we already have this is m1 is equal to over m, which is equal to -1 over m is 1 over 3, which is equal to the reciprocal is equal to -3. -3. So now it says also to get the equation of the line. If you take a general point here, point xy, on this line, point xy, you can say the change in y over change in x is equal to m1. But we already have m1, or the gradient. Change in y we can say is y, which is the general point, minus our point here 2, all over x minus 1 is equal to -3. Cross multiply, y minus 2 is equal to -3 x minus 1, which is y minus 2 is equal to -3x plus 3. Open that bracket. So that now you say y is equal to -3x, take the other side of the equation plus 5. So that is it. That's how you can find the equation of the normal and the equation of the tangent. We also have another question. The same question. We have done 5b. The same paper, we are going to do 5c. 5c. Locate the stationary points of the curve f of x is equal to x cubed minus 6x, x cubed minus 6. I don't know whether this should be 6x squared. Okay, because it's minus 6x plus 9x plus 6. I think this should have been 6x squared. I don't know. Maybe you try that 6x squared. Because it should be combined if it's not 6x squared. Add, determine the year nature. And determine their nature. I'm not sure whether you should collect a question in the exam. I would advise you not to correct it. So what you do when you want to locate the stationary point, what are the stationary points? Suppose you have a curve of y now this y, this x. This point here is called a maximum point. Maximum point, or point of maximum. This is a minimum point. This is here, somewhere here. Point of inflection. So the 3 points in general, they can be called stationary points. Or critical points or turning points, whichever name you wish to use. Now, at points where we have the stationary points or turning points, the derivative of y with respect to x is equal to 0. That's something we should note. Derivative of y with respect to x is equal to 0. Then, to differentiate between maximum, minimum, and stationary points, to know which is a maximum point, which is a stationary, to know which is a maximum point, which is a minimum point, and which is a point of inflection, we will need to get a second order derivative of y with respect to x. Second order derivative of y with respect to x. If the second order derivative of y with respect to x is negative at that particular point that we have found, then that point is maximum point. If the second order derivative of y with respect to x is positive, then that is a minimum point. But if the second order derivative of y with respect to x at that particular point whose nature you want to determine, if it's 0, then that is a point of inflection. So for maximum points, second order derivative should be negative. For minimum points, second order derivative should be positive. And for point of inflection, second order derivative should be equal to 0. So let us go back to our question with that knowledge. So what we need to do, maybe you can call this one, the whole of this expression y, but you don't have to. You can say derivative of the function of x with respect to x is equal to, this will be equal to 3x squared minus 12x plus 9 at points where turning point exists. We know derivative of our function f of x with respect to x will be equal to 0. So simply equate this with 0. 3x squared minus 12x plus 9 is equal to 0. So you need two numbers, their product is 27. We want to factorize two numbers whose product is 27, but sum is negative 13. Not negative 13, negative 12. I think those two numbers are negative 9 and negative 3. Negative 9 and negative 3. So we can now say 3x squared minus 3x minus 9x plus 9 is equal to 0. 3x, this is 3x squared minus 1 minus 9 x minus 1 is equal to 0. From this, if you can say now, factor out x minus 1, inside the bracket will be left with 3, when you'll be left with 3 and negative 9, so that will be 3x and negative 9 is equal to 0. So that either of them could be equal to 0, which means x is equal to 1, or x minus 1 is equal to 0, x is equal to 1, 3x minus 9 is equal to 0, 3x is equal to 9, x is equal to 3. So turning point exists. At point where x is equal to 1, and also at another point where x is equal to 3. We should now determine the nature of the critical points. how do we determine the nature of the critical point? We need how to get the second order derivative of the function with respect to x. So we get the second order derivative of y with respect to x is equal to what? We just go back here, differentiate again. If we differentiate again here, that will be 6x minus 12. The second order derivative of function at point x is equal to 1 is equal to what? This is 6 minus 12, that is negative 6. So this is a maximum point. But we can get the value of y in this case, 0.1, comma. If we are allowed to get the value of y, we should substitute the value of x here. X is 1, that is 1. 1 squared is 1 minus 6 plus 9 plus 6. So this is 15. 6 plus 9 is 15. So this 6 and this 6 you cancel out. So you have 9 plus 1, that is 10. Is a maximum point. Is a maximum point. Then you get the second order derivative of the function y with respect to x at point x is equal to 3. What's the value of that? That will be 3 times 6 is 18 minus 12, this is positive 6. So point x is 3. What's the value of y? You can also get the value of y. Using this equation, you can get the value of y. Is a minimum. Is a minimum point. Is a minimum point because the second order derivative is positive. This one is a maximum point because the second order derivative is negative. So that is it. That's how you get the stationary point when you are given a function of one variable. But the upside later, we will solve a problem where we will be given a function of two variables. So that is it. So we'll stop at that point. Remember to like the video, share the video with other engineering students, and also leave your question as a comment in the YouTube channel. We said liking the video, making comments, and also sharing the videos help to improve what we call search engine optimization or SEO, and that helps the video to be suggested to even more people so that the channel can grow. Also, watching the videos online is also helpful. It also increases watch time, which also improves the SEO. So watching the videos online will also be very helpful in improving the search engine optimization. Let us try a different one in the next video.